Hello everyone and welcome to today's lecture on the structure of materials. We're going to explore how the arrangement of atoms, ions, or molecules can define not only the identity of a material, but also its chemical and physical behavior. Throughout this session, we'll look at what makes a material crystalline or amorphous, delve into the building blocks of atoms, and discover how electrons, protons, and neutrons play their parts. We'll even discuss the fascinating role that valence electrons have when atoms form bonds. Let's get started. Now, let's move on to our topic, the structure of materials. Here, we define structure as the way atoms, ions, or molecules are organized within a material. Essentially, this arrangement is like a blueprint that has a major influence on how a material behaves, both chemically and physically. We categorize materials into two main types, crystalline and amorphous. Crystalline materials are those where atoms are arranged in a very regular and repeating pattern, almost like the perfectly arranged tiles in a mosaic. This regular pattern influences properties such as melting point and conductivity. In contrast, amorphous materials lack this long-range order, which means their atoms are arranged more randomly. Think of it like a loosely shuffled deck of cards, still functional, but without the pattern that characterizes crystalline structures. This simple difference in structure can lead to vastly different properties in everyday materials. Next, we shift our focus to the very small components that make up all the materials around us. Everything we see is composed of atoms, and within these atoms there are even tinier particles, electrons, protons, and neutrons. Imagine atoms as tiny solar systems. Electrons, which you can think of as the vigilant outer guards, reside in the energy levels or shells surrounding the nucleus. They are crucial because they determine how atoms interact and bond with one another, thereby influencing the material's physical properties. This slide sets the stage for understanding how these subatomic pieces come together to form the matter around us. Building on our previous slide, let's take a closer look at the roles of protons and neutrons. Protons can be thought of as the positive team members, located in the nucleus at the center of the atom. The number of protons in an atom not only defines its atomic number, but it also serves as its unique identifier, much like a fingerprint for each element. On the other hand, neutrons, which are found alongside protons in the nucleus, carry no electrical charge. Their role is to balance the positive charge of the protons, contributing to the stability of the atom. In this way, each component, electrons, protons, and neutrons, is vital in creating the diverse range of materials that we encounter every day. Together, they define the chemical characteristics and the physical properties of the material, playing distinct yet harmonious roles. Let's transition now to a fascinating area, the impact of valence shell electrons. The valence shell is simply the outermost layer of an atom where its electrons reside, and it plays a key role when atoms bond together. If an atom has one or two electrons in this outer shell, it is generally more inclined to form ionic bonds by transferring electrons to or from other atoms. This process creates charged particles that attract one another, somewhat like magnets sticking together. Conversely, if an atom has around 4 electrons in its valence shell, it tends to form covalent bonds. This means that instead of transferring electrons, atoms share them with their neighbors, forming a more balanced partnership. The type of bonding, covalent, or covalent, greatly affects how the atoms arrange themselves in a material. Think of it like following a blueprint. The bonds act as instructions for how the atoms should organize, which ultimately determines the unique chemical and physical properties of the material. As we approach the final slide, if there's additional content, this is where you would integrate further details or perhaps a summary of the previous points. In many presentations, this slide could also serve as a transition into questions or discussions. If this is intended for wrapping up the lecture, let's take a moment to review what we've covered today. To wrap up, we've explored the foundational structures that define materials, From the arrangement of atoms to the specific roles of electrons, protons, and neutrons, we learned how these tiny components and the bonds they form, driven largely by the behavior of valence shell electrons, contribute to the overall properties of materials. Remember, the way atoms bond and arrange themselves isn't random. It's the secret recipe behind everything from the crystals in your smartphone to the amorphous glass in your window. Thank you for joining me today. I hope this session has provided a clearer understanding of the fascinating world of material structures. Looking forward to our next class session together.